Hello. The goal of this project is to study the new game animation sample that they did in Unreal 5.7 and all those new animation technique and systems that Epic are constantly adding to Unreal. And in this particular video, we will be looking at the character with mover. So mover is the new system that replaced the old character movement component. And we will be creating a simple, minimalistic, mover-driven character with replication. So if you look at the game animation sample, you can see that it's very complex. There's a lot of systems, a lot of things going on. So what we will do, we will try to break that down into small parts, into small systems, and then try to understand them one by one. And then this way we will have a big picture. Of course, this is not possible to do in one video, and I plan to make more of them. And this time I decided to do something like more professional, like other content creators, YouTubers here are doing. So I will make a Patreon, and on this Patreon you will be able to download the source code, the project files for all those videos. And so if you think this project is interesting for you and worth doing, you can support me and join the Patreon. I will put the link in the description. So let's get started with this first video, and let's create a simple, minimalistic third-person character with replication using blueprints and using mover instead of a character movement component. Okay, so let's start making our minimalistic mover blueprint only replicated character. Here you see the preview of the final result we will be making. So if you want the game animation sample character is like a very complex and sophisticated character you can put in AAA game. And this one we will be making, it's like a you know, third person sample project, but made with mover. So this is really the base, and we will see what we need to do to create the basic mover functionality. So first of all, I created a new project from the blank template, so I don't even use it, the third person template, something like that. And the only thing I took from the game animation sample is the input config, input folder, where you have the input actions and the input context, because I don't want to remake all this. And then we need some more setup. So of course we need to enable the mover plugin. So this one, we don't need the rest for the moment. And I also check it in the project settings, project network prediction. I remember that in the old mover examples that came with mover plugin, you had to change stuff here. And so I copied the settings from the new game animation sample. It seems that they changed the requirement. I didn't see that explained somewhere, but I just copied what they had in the game animation sample. So the three things I changed is that preferred ticking policy is set to independent instead of fixed. Simulated proxy network load is set to interpolated, and this checkbox is unchecked, fixed tick smoothing. So that's it, how it is in the game in the game animation sample project. And with this we can start to making our character. So here I already made one, but I will show you the important steps. So first of all, we will create a a new blueprint class pawn. So we don't use character anymore, pawn. And as I understood, the mover can also work with any actor. So you don't need the pawn. You can just move anything you want. But here we make the player character, so it makes sense to use pawn for the input and the player controller stuff like this that we still need. I will call it pawn 2 because I already have the other. Okay, so I open it. Okay, so the first thing we will do here in our new pawn, we will go into class defaults, replication, and we will uncheck this replicate movement because our replicate movement will be handled by the mover. We don't need this. And next we will create our structure of components. So if we go into the game animation sample character, we can see that the structure is actually quite similar to what we have before. So we have capsule, skeletal mesh, spring arm, and camera. So we will do exactly the same. Here add capsule, and then make it root, add skeletal mesh, and then add spring arm, and then add the camera. So far so good. So we have this now. We need in the skeletal mesh we will be use a mesh that is coming with Unreal. Let's call it it's called tutorial TPP. This one, that's the old money. And then capsule, we need to make it bigger and wider. And we need to move the mesh down. You know, the usual stuff, nothing really new here. Rotate it. And the capsule, we need to check the collision presets and make it pawn. Okay. And last thing in the spring arm, we need we need the spring arm to follow the control rotation. So we check here camera setting, use pawn control rotation. And that's more or less our setup. Compile, save, and what I will do, I will check this one, put it here, and here check auto possess player 0. Comme ça, like this we can quickly test things. So of course now if I hit play, nothing will happen because now we need to add input and the mover to this car. To set up the input, I will copy the function setup input from the animation sample project, which is again the typical classical setup input function that set the mapping context. And then I will, in the event graph, add the event possessed, and I will for now just call this function. So now we can use the various input actions here. And first thing we will add is the camera control. And for this, there is nothing actually different from the old system. We will take this enhanced input action AI look, which is you know, the mouse movement or the joystick movement, and we will simply add this input to the controller. And this is like before. If we compile, save and check the result, we can now rotate the camera. It works. And now we will add the new stuff. So with the old system, we would here add those input actions for move, etc. And with mover, it's completely different. Now we have to here go to the class settings, and in the implemented interfaces here, click add and search for mover. And we have mover input producer interface, and we add it. And when we add it, we have the here this function that is added, and that's the function that will be called by mover, and that's the function where we will take the input from the keyboard and mouse, etc., and we will give it to mover as the input command. And now we will look how to create this function. So the idea here is that we give to the mover this input command result, which is a struct with just one entry, input collection. And this input collection, here we will create just a variable for it, call it out collection. This collection will contain user defined or predefined structs that mover will give to the movement modes, and the movement modes are supposed to understand them. So we will use, we didn't add mover yet, but we will use the default character mover, which comes with the default moves, movement modes. And for this, we need to add a variable, a struct of the type that it will understand. So here we add a variable, and we call it, for example, inputs, and the type is character default inputs. So if you look at this, if you break the struct, you can see it has those entries, and you have like move input. It's basically in which direction you want to go. You have orientation intent, control rotation, is jump preset, etc. So that's the various variables we have to set here. and we don't need to set them all, some of them. And that the variable that the mover will take and give to the movement mode, like walking movement mode. And this system, this data will also be replicated when we have a multiplayer character, we have a clients. This thing will be replicated to the clients, so they can also execute on this. So let's see. We need here really a minimal thing. We need to directional input, so where direction we are going and the speed. And we need the orientation of the character. So what we will try to do is to reproduce the orient rotation to movement kind of behavior. So first we will add to directional input, and for this struct, it has a special function. You don't set the struct member directly, but you pass through this thing because it will do something with this directional input, sanitize it in some way. So here we have this, and which we are supposed to give here is basically the direction, the vector, the input vector from the keyboard or from the joystick, but in the world space. So here I already prepared the code for that. This code, you find it in the project on Patreon. And here it's very simple. And that's the same code that is used in the game animation sample project. So we have our input action move, which is basically WASD or the joystick. And we will, for security, clamp it between 0 and 1. And we'll swap those two here, because on the keyboard, on the joystick, the Y is the forward axis, if you want. It's the vertical axis, but our characters point forward the X axis, so we need to do this. And then we get the control rotation of the pawn and rotate this vector. So this input vector will now look the same way in the world space as the pawn is looking. And then for more security, we normalize it, and then we give it here. And so this way we have our directional input set. And next we want to put the orientation. And as I said before, we want to do create the orient rotation to movement kind of behavior. So we will just take this direction input from the inputs and give that as our orientation, our desired orientation. So I already prepared also this code. Here it is. And here, as you can see, we take our input struct, we break and we take the move input, basically this thing we put here, but sanitize it, and then we set the member correct orientation intent, so where we want to look, and the mover, or more precisely the movement mode, will then interpret this, so it will like accelerate our character in this direction with this speed, and then rotate our character progressively towards this orientation. Now we created this struct. That's all for a moment. For this example, that's all we need. And then this function. Sorry. So we will take our inputs and we will add it there to the collection. Local variable here. So as you can see here, we can add to this collection, we can add any struct, but I suppose just once. So this is wildcard. So we add this structure and then we take this collection, we pack it again in the input context and we return it. And so that's how we give the input to the mover. But of course, last thing we need here is to add the mover itself. So let's go and add it. We will go into add components, search for mover, and we'll take the character mover. That's the same that the animation sample project is using, because there are different movers. And this one is the one that looks like and like it's compatible to character movement component. Like it takes the same kind of parameters. So we will plug it here. And so we need what we need to do here. It comes already predefined with 3 movement modes. And so one thing I will do here is just to change the movement mode to smooth walking mode. And the 2 others I will keep as it is. For the moment, I don't touch anything else. And now we compile it, we save it, and let's check out if it works already. I hit play, camera works, and now I can move. Of course, we don't have any animation yet, which is cool. So now let's look at the animation side of things. So let's create the anim blueprint for our pawn. Here we look for our skeleton. Call it MVP pawn 2. Cool. And we open it. So we will not doing here anything complicated because as you can see in the animation sample project, there's really some nice and advanced techniques, but here we will really look at the basics, and we look to how we can transmit data from the mover to the anim blueprint. And so first of all, we have this event blueprint update animation as usual. What we will do, we will get component by class. We will find our mover component, and then if it's valid, so of course it would be better to execute it somewhere once in the beginning, but for the sake of simplicity we do it here. And then if it's okay, we can do 2 things. First, we can get the values, actual values like speed of the character from the mover. Get velocity. And then we can also find the last input command, which we just, created in the produce input, this thing, and access it. And for this, we will use the function called get last input command. And if we want to find our structure, we use the function called sorry, we have to break it again. As you remember, it has just one entry, but we have to break it. And from this collection, we can get the data. So again, it's a wildcard. So we will here again create a variable, call it input, character default inputs, put it here, and then we can read some of those inputs. For example, we can split it. If, for example, get move input, that's our movement input. That's the, if you want acceleration input, the movement input involves space, and you can do something with it, like find the vector length so we know if we are moving or not. Or we can take the velocity, take the length, and then we will have the actual velocity of the character and the level. So we will be using this here, and we will promote that to a variable called velocity and use that in our anim graph. And for example, we will also check if it's greater than 0 if we are moving, and then promote that to a variable is moving. So that's how you access those things from mover. Now from the anim graph here, as I said, I will don't do anything complicated. I will in the next videos look at those new techniques and chooser, stuff like this. And here I will just put a simple, I would say classical, a very simple anim graph, which I already prepared here. So we have the state machine locomotion, in which we have two state, idle, call it wait here, and move. And we have those two transitions from one to another. So you can go from idle to move if the character is moving, which is bind to the variable is moving here. And then you from move to idle, you normally go when it's not moving. Nothing fancy here. And in wait, I will play this animation which comes with this character idle. And in the move, I will play the blend space, also coming with this character, which has a very original name, new blend space 1D, and it will be driven by the velocity we just calculated here before. So that's it. That's our locomotion. If we compile, you can see already here the guy is in idle state. Now if I go here and I play, it does nothing because I forgot to set it up. So we go to Pawn, skeletal mesh, use animation blueprint, and we will simply put it here. So now we have our animation blueprint linked to the character. See already. And now if I run, it works. So the speed is still incorrect. We will change this now. But it's almost working. So in the character mover, so as I said, it's like compatible with the old character movement component. It has the same here options parameters. So I will put here the max speed, something smaller. Also maybe change this, something smaller. And now we walk with like appropriate speed. So we made our single player character, and now we have to make it multiplayer. And this is pretty easy. We don't need this anymore. So to make our character multiplayer, one thing we need to do is in the character mover set that it will replicate the inputs to the clients. And this is done with just one click, which is sync inputs for sim proxy. That's one thing. But we also need to set up the controls correctly, the inputs. So for this, in the event graph, we need a little bit more than what we did. We actually need to create a new custom event. We'll call something like that, processed replicate. And this one will be replicated to owning clients. And that's this event will call the setup input. And now this event processed, which is run on server, will call this event. Okay, I believe this is correct. I'm just double checking on my other screen. Yeah. So we compile, save this, and now in the map here I already have a game mode. So I will now replace the pound here. I put my new pound. This one I don't need anymore. And so we have 2 player starts. And I will now put the game here in the multiplayer, players client, and number of players 2. And I will play in new editor window. So we have 2 little windows here. and we can start to move one, and you can see everything works. Now I can try to move this one. It also works. So that's it. We have our replicated mover-based character made with Blueprint. And I think it's a good point if you want to play with mover and all those new tech. It's a good starting point. And so, as I said, I put the project file on Patreon. They are all commented and everything. And if you couldn't exactly follow something, you can find here everything that works. Thank you very much for watching this video until the end. And if you have some suggestions, please leave that in the comment. And in the next video, I will continue to dig into new animation sample and try to explain and understand other new features, more advanced this time. Goodbye.